Okay, so today we're going to look at the equations of motion, right? Now, this is a funny wee one because see, I keep putting this on the course and taking it off the course, and the reason that we do it is that there's a couple of these definitely make some of the questions a lot easier to tackle. Okay, so the equations of motion apply if you have something that is travelling with a constant acceleration, and all the questions that you'll be dealing with will be a constant acceleration. We'll never have any questions with a variable acceleration, which means we'll be able to use these. Okay, so if an object is travelling with uniform, which means constant acceleration in the straight line, we have this set of equations that we can always use to calculate different values about its journey. Now, these are probably the most awkward looking equations that we've seen so far this year in physics, but you already know two of them, right? So this one here, v equals u plus at, I talked about it the other day in one of the examples we were doing. This is just the same as the acceleration equation. So this is the same as a equals v minus u over t. So you're writing in everything that I am writing in here, yeah? Now we haven't seen these ones, but I should have said actually the letters that we use in here are the same letters we have been using. So I'll look at that before I go on to any of the other equations. So use the starting velocity or the initial velocity. V is the final velocity, A the acceleration, S the displacement, and T time. So it's all the letters that we're used to using. Okay. So another one, V squared equals U squared plus 2AS. This one is new to you. And S equals UT plus a half AT squared, also new to you. Now, this here one is the one that definitely makes some of our questions a little bit easier. Okay, so bear that in mind. I know it looks a bit more awkward than what we're used to, but definitely does make life a little bit easier. Now, this one here, you maybe don't think that you know it already, but you do. So this one here is actually distance equals average speed multiplied by time. Okay, so this is the same as distance equals average speed multiplied by time. Because do you remember that equation we learned about average speed where you added the starting velocity and the final velocity together and divided by 2? Well, that's that, a half u plus v, and then you're multiplying by time. So technically we already know these two, we just know them in slightly different forms. These two here are new to us. Okay, we're going to do some examples using these, and I'm going to show you for a couple of them anyway, a couple like two different methods. One method using these and one method that you would use if you hadn't learnt these equations. Okay, so page 172 then. A cheetah starts from rest, so that means u is 0, accelerates at 2 meters per second squared for 10 seconds, calculate the final velocity and then the distance travelled. So our solution that we're going to do first of all is the one using these new equations of motion, and then we're going to do the way you would have to do this question if you didn't know the equations of motion, which is actually way more awkward. Okay, so for part A, finding the final velocity. Anytime we are using these, we'll make a little list of whatever information that we know, and the way that we most commonly list it, you'll hear me talking about list UVAST or the UVAST equations. That's these equations. Okay, so remember we already know what all these letters stand for. So U is the initial velocity. Because it started from rest, that's 0. V, the final velocity, that's what we're trying to find, so I'll put a question mark at that. Acceleration, it told us in the question, was 2. We don't know the displacement, but we do know the time is 10. Now, one thing that I like to do as well is I only put the question mark at the thing that the question is asking me for, because it makes it easier for me to pick one of the equations to use. So your next thought is, right, let's see what letters I have and then what equation I can use. So I'm thinking, what equation do I know that links U, V, A and T? Okay, and before you get used to them, you might start and at the top of your page whenever you're doing these have all your equations listed out, but after a while you will get to know them. So what equation links U, V, A and T? V equals U plus AT. Okay, so v, u is 0, a is 2 multiplied by t, which is 10. So our final velocity is 20 meters per second. Okay, so part A, easy enough. Then B, I'm now looking for S, and because I've got all my other letters, I can use any of my equations. So I'm going to use one that means I'm not using that final velocity that I've just figured out, because if I did this wrong, it's going to make the other one wrong. So I'm thinking, what links S, U, A and T? Well, S equals UT plus a half AT squared. Okay, so S, U is 0 multiplied by T, which was 10, plus a half multiplied by A, which is 2, multiplied by T squared, 10 squared. 0 multiplied by 10 is 0. Half times 2 times 10 squared is 100. So my displacement is 100 meters. Okay. Let's do the same question, but with this alternative method. Okay. So not using UVAST. Okay. Okay, so I've just folded my page up so I still have the question there, right? So if I didn't know these UVAST equations, right, let's do the same question. Theta starts from rest, so I know the U is 0. I'm still going to list it. Accelerates at 2 meters per second. A is 2 for 10 seconds. Calculate the final velocity. Okay, so the first part's basically the same. I'm going to be using my acceleration equation, because if I hadn't learned V equals U plus AT, that's the version of that equation that I would know. So A equals V minus U over T. A is 2, V is what we're looking for, U is 0 and T is 10. So if I multiply both sides of my equation by 10, I'm going to get 20 equals V minus 0, so V is 20. So pretty much straightforward so far. But for B, the distance travelled. So a common mistake that people will make here is that they will use distance equals speed times time, okay, and they'll use that final velocity, they'll use that 20. But that only works if this cheetah was going at 20 meters per second the whole time, and it wasn't. So we need to figure out the average velocity first. So let's make a little list. So if we didn't know our UVAST equations, these are the steps we would have to take, and any time there's a solution that involves more than one step, that is when people find it tricky. So that's why we like to give you these UVAST equations. So if we're trying to find the distance travelled, we're first of all going to have to find out the average velocity, and then we're going to have to use the average velocity equation. So to figure out the average velocity, we're going to have to use U plus V over 2. Okay, so the initial speed was 0, final speed was 20 over 2. So the average velocity for this journey is 10 meters per second. Then we would have to use that in our average velocity equation. So average velocity is the total displacement divided by the total time. So 10 equals, displacement is what we're looking for, and the time was 10 seconds. So we end up getting the same answer, 100 meters. Okay, I find this second method a little bit more long-winded, just a wee bit more awkward, but if you prefer that, that's fine. I know it's easier for me because I do remember these equations off by heart now because I use them all the time. They're probably my favourite area of physics, but it's up to you. Both would get you full marks. Okay, over onto page 173 then, let's look at example 2. So a ball is thrown vertically upwards at 20 meters per second, ignoring our resistance, taking G to be 10, calculate all of these things. Now, for stuff like this, it definitely helps me if I draw a little diagram and label different things on. So here's the ball. It gets thrown up the way, and it's thrown up initially with a speed of 20 meters per second. Okay, now whenever you throw something up, it's going to come back down and the motion is going to be symmetrical. So it's going to reach this stopping point at the very, very top, and then it's going to come back down again. Okay. Now, in these questions, it definitely helps if you split this into two. So I'll do that whenever we get to it in the question. Okay, but for now, if we just draw that in. So first thing we have to calculate is how high it goes. So we've got very, very little information here. Oh, I forgot to mark on acceleration due to gravity. We tend to mark on accelerations with a double arrow. So it's 10 meters per second squared down the way. And that's important because look, this initial velocity is up the way. So for part A, to calculate how high it goes, I'm going to only use the first half of the motion. So this first section here, which goes from the second it was thrown to the very, very top of its flight. Because if I do that, that gives me an extra piece of information that I can use. Okay, so for section 1, just the very first half of the flight, the initial velocity or the initial speed is 20 meters per second up the way. The final velocity is 0 because it stops very briefly up at the top there. The acceleration is 10 meters per second squared. But see the way that's in the opposite direction? If I've put my 20 in upwards as being positive, then my 10 meters per second squared down the way has to be negative, because remember, vectors have direction. Displacement, I do not know, and time, I do not know. The question's asking me for how high it goes, so that's the displacement. So I'm looking at this and I'm thinking, what lengths u, v, a and s? V squared equals u squared plus 2as. Okay, so let's substitute in our values. V is 0, u is 20, 2as means 2 multiplied by a, which was minus 10, multiplied by s, which is what we're looking for. So 0 equals 20 squared is 400, 2 times minus 10 is 20, minus 20, minus 20s. So to solve this, if I add 20s to both sides, I'll get 20s equals 400. And then to get s on its own, I have to divide by 20. So s equals 20 meters, fourth row. Okay. Right, B is asking for the time taken to reach that height. So I'm going to figure out the time taken just from down here up until that very, very top bit there. Okay, so that means I can use my same UVAS list that I had used up here. So now I'm looking for the time and I want to use U, V and A. So U, V, A and T. V equals U plus AT. Fill in what we know. So V is 0, U 20, minus 10 T. Add 10 T to both sides. Divide by 10 and we get 2 seconds. Happy enough for that? C, the time taken to return to its starting point. Now, I said earlier there that journeys like this are symmetrical. So if it took, how long was it, 2 seconds to get up there, it's going to take 2 seconds to come back down again. Because there's no other extra forces acting or anything. The acceleration is always 10 meters per second squared the whole time. So for part C, the total time is going to be 4. And then for part D, its velocity when it returns to its starting point. Well, see here, if it started at 20, decelerated at 10 and ended up at 0. If it's doing the exact opposite of that on the way back down, it's starting at 0, accelerating with the same rate of acceleration as it went up at, it's going to be at 20 meters per second down the way here. Okay, so for D, 20 meters per second downwards. Right, so for example 3, a toy car is rolled along the ground. From the instant it is released, it decelerates uniformly at 2 meters per second squared until it stops. Find its average speed for the journey, if its average speed for the journey is 3 meters per second. what was its maximum speed? How long did it take to come to rest, and how far did it travel? So let's look at A first of all. Right, I'm going to have to go back and look up here. We know its average speed is 3. We know it came to rest and it has a uniform deceleration. So we're actually going to use our average speed or our average velocity here. So our average velocity is going to be u plus v over 2. I'm just going to work across so that I have room here. So starting velocity is, oh sorry, I can't do that there. Can't work across the page. This is the bit that we do know. So we know the average velocity is 3. Starting velocity is going to be the maximum speed, which is what they've asked for, because it starts off as fastest and then slows down. So u is what we're looking for. V is 0 all over 2. Multiply both sides of our equation by 2. 6 equals u plus 0. So that means u 6 meters per second. The starting or the maximum speed was 6 meters per second. Okay, B. How long did it take to come to rest? For this, I'm going to list my UVAST. So we now know u is 6, came to rest, so v is 0. Its acceleration, it did tell us in the question, didn't it? Yep, it decelerates uniformly at 2 meters per second squared. So that's an acceleration of minus 2 meters per second squared. And we're asked for the time. So we're thinking, what equation links u, v, a and t? V equals u plus at. So v is 0, u 6, minus 2t. Add 2t to both sides. 2t is 6. Divide by 2 and we get 3 seconds. And then the last part for C, how far did it travel? So I can use this UVAST list and I can use any of my equations. See, because I've just figured out that t, I'm going to try and not use that. So I can use v squared equals u squared plus 2as. Okay, so v is 0, 0 squared is 0, u 6 plus 2 multiplied by a, which is minus 2 multiplied by s. 6 squared is 36, minus 4s. Add 4s to both sides. Divide by 4, 9 meters. Okay, so that is a wee bit of a step up from what we have been doing, but do take your time to look over those properly. One last thing I want to look at, and that is just on page 175, the useful points to remember here. So these are just tips to make these questions a little bit easier for you. So if you start every question by listing u, v, a, s and t, fill in everything you know from the question, put a question mark beside what you're trying to find, guarantee that makes it much easier to pick what equation it is you have to use. Look out for wee things in questions like if something's starting from rest, that means u is 0. If it's dropped, that means it's starting from rest, and they won't necessarily have said that, but if they say something's dropped, starting speed is 0. If it finishes at rest, then the final speed is 0. Questions won't always spell information like that out. You need to be able to interpret the information in the question. You will not be told otherwise, but unless you're told otherwise, take acceleration due to gravity to be 10. Well, suppose if you're on another planet, then it wouldn't be 10, but on Earth, 10 meters per second squared. Very careful with units. Sketch like I did in that wee example with the ball that was getting thrown up really helps. And pick one direction to be positive and stick to that throughout the question. So like I did here in this one, because I had listed this upwards velocity of 20 as being positive, that meant the downward acceleration had to be negative. So that was me picking a direction to be positive and then sticking to it throughout the question. Okay, that's it. Bye.